Andromeda is made up of a very large galaxy of stars, like our own Milky Way. Our friend in space is about 2.5 million light-years from the Milky Way. The way we study Andromeda has changed a lot since it was first discovered, from using telescopes on the ground to using space telescopes like the Hubble and James Webb Space Telescope. We have come a long way with each new piece of technology, reaching new heights and learning more about the Andromeda Galaxy. Given that we now know more about its structure, Andromeda has become a standard for studying how galaxies form and grow. This has given us more information about how the universe works in a bigger sense. Scientists think that we need to study the link between Andromeda and the Milky Way to learn more about the universe. This is especially important since the two galaxies will eventually crash into each other in about 4 billion years. Even though research and studies have moved forward, the James Webb Telescope recently received a signal from Andromeda that has caused some concern. Scientists all over the world are confused by this worrisome signal, leading to questions about where it came from and what it might mean. The advanced sensors on the James Webb Telescope have detected strange behavior right in the center of Andromeda. The signal sent back to scientists shows results that are very different from what has been observed before, which has intrigued scientists globally. The signal indicates that there are significant events happening inside the galaxy, which might be related to its giant black hole or things that haven't been seen before. One of the most recent discoveries is that Andromeda's mass might be much larger than the Milky Way's, changing how we think about the sizes of both galaxies. The James Webb Telescope has also captured very clear pictures and spectra of Andromeda, revealing how new stars are made and what chemicals they are composed of. This new information is crucial for understanding how galaxies have evolved over time and what conditions might be right for life. The telescope's data also shows that Andromeda's active galactic center is becoming more active, which will affect its surroundings and determine how it will be structured in the future. Researchers are also learning more about how mysterious dark matter is distributed in the galaxy by studying the effects of gravity on stars in Andromeda. This will help us better understand how dark matter affects the physics of the universe, as it remains one of the biggest mysteries in astronomy. Recent discoveries made by the James Webb Telescope have sparked many studies around the world as astronomers try to understand what is happening in Andromeda. We now know more about the past and future of the galaxy, thanks to new knowledge that has come to light. Andromeda has some amazing features that set it apart from other galaxies in the universe. People are astounded by its size, with new estimates putting its width at about 220,000 light-years, making it one of the largest galaxies in our group and even larger than the Milky Way. Its mass comes from its immense size, and it is made up of about 1 trillion stars, which is more than our galaxy. Scientists are also fascinated by the galaxy's structure. Unlike most spiral galaxies, Andromeda's center bulges, and its dense core is surrounded by rings of dust and gas, providing a great environment for star formation. One of the most interesting features of Andromeda is its center, which has a double peak emission, suggesting the presence of a supermassive black hole. This black hole is similar to, but not the same as, the one at the center of the Milky Way, offering important insights into these massive cosmic objects. Andromeda is also surrounded by a sphere of stellar debris that spans hundreds of thousands of light-years, composed of stars, planets, and globular clusters. This surrounding space tells an intriguing and comprehensive story about how the galaxy came to be and its past. The 460 globular clusters found in Andromeda provide crucial information about the early stages of star formation, making it easier to understand how star clusters form and how the galaxy itself first developed. Astronomers are getting closer to understanding the role of dark matter in the grand scheme by piecing together the puzzle of Andromeda, but one lingering question remains. How can they explain the mysterious nature of dark matter and its impact on the movement of galaxies? Additionally, Andromeda has more than 20 smaller galaxies orbiting around it, making up its halo structure. Some of these smaller galaxies are losing their stars and gas due to the tidal forces exerted by Andromeda. This process shows how cosmic evolution is active and demonstrates how galaxies grow and interact with each other over time. Looking ahead, the future of the Andromeda Galaxy is closely tied to its collision with the Milky Way, which is expected to occur in about 4 billion years. This collision will not only lead to a merger of the two massive galaxies, but will also result in the birth of a new galaxy. Despite the catastrophic nature of the collision, It is considered a normal part of the way galaxies grow and evolve. During this event, the gases and dust from both galaxies will combine, and new stars will be born, creating a spectacular cosmic show. Eventually, the collision will lead to the formation of a single, irregular galaxy. This kind of cosmic event, although destructive, has occurred many times throughout the universe's history. The fact that we are able to witness and understand it makes it all the more fascinating. Adding to the drama, the merger of the supermassive black holes at the centers of both galaxies will further heighten the spectacle. This interaction could cause massive blasts as matter is sucked into the black holes, releasing tremendous amounts of radiation. This process not only provides insights into how galaxies change over time, but also raises an important question. What will happen to our solar system after the merger? Although the solar system won't be destroyed entirely, its trajectory and conditions could change drastically. The orbits of the planets could shift, or they could even be ejected from the newly formed galaxy. Scientists are studying similar cosmic events to better understand how this process works and predict what will happen to our galaxy in the long run. Given the vast distances between stars, it is unlikely that star collisions will occur during the merger. However, the gravitational forces at play could disrupt the orbits of stars, potentially altering the path of our Sun. Such a shift could have profound effects on Earth's climate, pushing it either closer to or farther from the Sun, leading to significant changes in temperature. If the Earth were to move closer to the Sun, it could become warmer, causing the ice caps to melt and sea levels to rise. Conversely, if it were to move farther away, a new ice age could begin. These changes could also disrupt the amount of radiation reaching Earth, making it more difficult for life to survive. The merging of Andromeda and the Milky Way, along with the changes it brings, highlights the complex relationships between celestial bodies. As time progresses, the black holes in both galaxies may draw nearer to each other, which could increase the amount of high-energy particles reaching Earth, potentially leading to a rise in cosmic radiation. This increased radiation could harm Earth's ecosystems and affect the course of human evolution. In addition to these profound changes, the merger will have lasting effects on Earth's natural orbit and axis, potentially altering the way settlements are spread across the planet. Climate change, in the form of shifts in biodiversity and ecosystem structures, is already occurring around the world. As the climate zones change, certain species may adapt, while others could face extinction. Furthermore, as gas clouds from the merging galaxies come together and form new stars, the radiation emitted from these young stars could dramatically alter the environment. This could have a significant impact on Earth's temperature and the entire ecosystem. These cosmic events play a crucial role in the evolution of the universe, but understanding what happened before and after them is equally important. The events surrounding the Andromeda collision, which will occur billions of years from now, will likely be beyond the scope of human experience. It is possible that humanity will have moved to a new home, either elsewhere on Earth or even beyond our planet. Exploring the Andromeda Galaxy is key to understanding how our own galaxy has changed over time and what the future holds for it. The differences between Andromeda and the Milky Way help refine our models of how galaxies evolve and interact. Reassessing Andromeda's size and mass is an important step, as it helps us learn more about the Milky Way and its structure. New information has forced us to rethink our initial ideas about Andromeda and its role in our galaxy's neighborhood. Contrary to previous beliefs, the Milky Way and Andromeda galaxies are now thought to be about the same size, which challenges our understanding of their place in the galactic group and their gravitational influence. Currently, the Milky Way appears to be a barred spiral galaxy, but when it interacts with Andromeda, which is likely to happen soon, its shape could change. Observing Andromeda's evolution over time helps us understand how large galaxies transform. By studying where Andromeda is now and predicting where the collision with the Milky Way will occur, cosmologists can better understand how star formation rates, gas and dust distribution, and the cores of both galaxies will be affected by the merger. The advancements in astronomical technologies have made it possible to create these models, expanding our understanding of space. This journey began when telescopes were first made in the early 1600s, allowing scientists to observe the movements of Jupiter's moons and the phases of Venus. Over time, telescope technology improved, leading to the discovery of new planetary bodies, such as Neptune, and enabling further exploration of the universe. While ground-based telescopes faced challenges from the atmosphere and light pollution, they still made groundbreaking observations. The launch of the Hubble Space Telescope in 1990 marked a significant step forward, providing a clearer view of the universe from above Earth's atmosphere and offering unprecedented clarity and depth. In addition to Hubble, other space telescopes like the Chandra X-ray Observatory and the Spitzer Space Telescope have further expanded our knowledge of the universe. These telescopes, along with others, have allowed scientists to observe the universe from space, free from the distortions caused by Earth's atmosphere. They have provided invaluable insights into a wide range of phenomena, from the microwave background radiation of the universe to the remnants of supernova explosions. Despite these advances, dark matter remains one of the most enigmatic and fascinating topics in astronomy. Dark matter constitutes about 90% of a galaxy's mass but cannot be observed directly. It can only be detected by its gravitational effects on visible objects, radiation, and the structure of the universe. Studies of Andromeda have revealed that the stars on its outer edges spin at the same speed as those near its center, contradicting earlier predictions. This suggests that dark matter and other unknown particles are influencing the galaxy. The presence of dark matter in Andromeda's halo, extending far beyond its visible stars, has a significant impact on the movements of star clusters and satellite galaxies. Research into Andromeda's dark matter halo is crucial for understanding its distribution and effects on the galaxy. This halo spans over 1 million light-years from the center of the galaxy and is composed mostly of dark matter, which is more concentrated near the center and becomes more diffuse further out. Dark matter influences the formation and evolution of stars and gas clouds, affecting the speed and location of new star formation. It also plays a key role in galaxy mergers, shaping the final structure of these cosmic events. One of the central goals of astrophysics is to identify the nature of dark matter. Understanding dark matter is essential for gaining deeper insights into the composition and evolution of the universe. As Andromeda and the Milky Way prepare to collide, their vast halos of dark matter will interact, influencing the formation of the new galaxy. Observing Andromeda helps scientists understand how galaxies formed and evolved in the early universe. Detailed studies of galaxy structures allow astronomers to learn about the smaller processes that shape galaxies over billions of years. These insights also help cosmologists adjust theories about galaxy formation to better match observations of the universe. By comparing the distribution of stars in Andromeda to the broader universe, scientists can refine models of galactic evolution. Signals from Andromeda are also helping to improve the cosmic distance ladder, making methods for estimating the size of the universe more accurate. These adjustments are critical for understanding fundamental cosmological factors, such as the Hubble constant, which measures the rate of expansion of the universe. By examining the stars of Andromeda and the chemicals they are made of, we can gain valuable insights into how stars are born, die, and contribute to the chemical enrichment of the universe. This research has deepened our understanding of nucleosynthesis and the early processes that shaped the cosmos. Through the study of Andromeda, we continue to uncover new layers of knowledge about the universe and our place within it. We continue to explore the Andromeda Galaxy. New technologies and advancements in space research will provide even deeper insights into its nature. One of the key areas of focus is the study of Andromeda's dark matter, which remains one of the most enigmatic components of the galaxy. Researchers are trying to understand how this invisible substance affects the structure and behavior of galaxies. Dark matter, which does not emit, absorb, or reflect light, can only be detected through its gravitational influence on visible matter. Its effects on star movements and galaxy formation are essential in understanding the overall dynamics of galaxies. In addition to dark matter, Andromeda's star formation processes are of great interest. As the galaxy continues to evolve, astronomers are keen to observe how stars are born and how this process differs from other galaxies. The intricate interactions between gas clouds, dust, and gravitational forces lead to the birth of new stars. By analyzing these processes in Andromeda, scientists hope to gain insights into how star formation occurred in the early universe and how it shaped galaxies over billions of years. Another crucial aspect of Andromeda's study is its interaction with nearby galaxies. These interactions can lead to the formation of tidal tails and stellar streams, which are important for understanding the evolutionary history of galaxies. The gravitational forces between Andromeda and its satellite galaxies are reshaping their structures, leading to the loss of stars and gas. These interactions offer a glimpse into the dynamic processes that drive galaxy evolution. Furthermore, as Andromeda and the Milky Way prepare for their eventual collision, it is essential to study how such cosmic mergers impact the behavior of supermassive black holes. The collision of these black holes will be a significant event in the history of both galaxies. By observing how these forces interact, scientists can learn more about the nature of black holes and their role in shaping galaxy dynamics.